Back to Engineering Conversations. Today we have our guest is an award-winning chartered structural engineer who believes there is nothing impossible. She wants to make an impact around the world as an engineer, a mentor, as well as a role model. She has an impressive track record of achievements. She initiated a graduate group, the Young Engineers Network, which was extended to 300 plus young engineers as well as apprentices globally in a 2-year period. She was also named as the best young woman engineer at the European Women in Construction and Engineering. She has also been named as a STEM leader at the Forward Ladies Northwest, Wales and Ireland as well. In addition to that, she was named as a top 50 rising stars in science and engineering by We Are the City. Who has also been named highly commended as an emerging professional at the ACE Awards. And in 2019, she was named as Northern Power Women from Najwa to Engineering Conversations.
Hi everyone, you've done a brilliant introduction, so hi.
Yeah, welcome to Engineering Conversations. Today we'll start with a few quick fire questions and then we'll delve into our conversation. What was the last book you read?
Last book I read it's actually completely different from engineering.
Okay.
It's called Think Like a Monk. So it's by oh God, I'm not gonna remember the name now. Yeah,
that's okay if you can remember the name. At least remember the title so we can go find the book ourselves. That's good.
Yeah.
Quality of life or quantity of life, which would be your choice?
I would say quality of life because I value every moment in my life. I enjoy being present in the current moment. So instead of thinking about what can be done or what I can't have, I think about what I have. But that does not mean I don't dream about the big things. I have big dreams. I have vision. I have impossible things which I want to achieve in life. But having said that, impossible also says I'm possible, so I am going to do something about it.
I like the answer. Next, what are some of the myths or misconceptions people have told you through your engineering career so far that has made you gasp?
The biggest one, being a woman in engineer, is the misconception about what a woman in engineering looks like. People think it's wearing hard hats, it's high vis. Yes, it is, but only for 5% of the time. If you want to be on site, yes, it can be 100%. But for me, being a design engineer is actually 95% of the work in office, working with the colleagues, talking, developing design, coming up with ideas. And then 5% I go to the site and then oversee what has been built is actually according to my design.
Thank you for the answer. Next, what's something they don't teach you in university that everybody should probably know?
I would say that engineering is fun and creative, but it is also a very risky environment. But when I say risky, what I mean is like you have to be careful about what you're doing in terms of design and calculations, because that is going to be built and you have everyone's lives in your hands. So this is something which is not taught in university. So it's that level of ownership you need to take of your design and be sure that what you're doing is not going to harm someone else.
Yep, safety is key. What inspired you into engineering? And did you always know that you wanted to be a structural engineer?
No, I didn't. I didn't even want to be an engineer. I sat down with my physics teacher in A-levels And then because I didn't know what I wanted to do, and we were exploring all my career options, and he wrote down a list of professions for me. All of those professions were engineering. And my first reaction was actually, why? But because I had that perception of engineering, women don't go together. So I was like, why would you want me to do that? And then he was like, just think about it. Just think about why not? And I looked through the list and I used the method of elimination. I started telling him why I don't want to do a certain type of engineering, because I literally just said, I know all of those answers were wrong, but that was my opinion about it. I said, I don't want to do mechanical because I don't want to be greasy and oily. So I don't see myself doing that. I wanted to be electrical because I don't care what the wires are carrying and what, I had no interest in it. Even though I actually had best marks in those subjects because it was all part of physics, right? How does the fluid move from one point to another? How does the mechanics work? It was all part of physics, but it's just that I had that opinion about a certain image about all of those sectors. When I got to civil and structural, I couldn't find an excuse to reject it. And that's why I'm a structural engineer, by the way. But the thing is, what I would say is, just because if you don't know what you want to do does not mean you will not get there. So it's all about exploring different things. Luckily, I chose the one because I couldn't reject it. I went and applied for civil and structural engineering degree in the University of Leeds. I did my first 2 years, and then I got a summer placement with Jacobs Engineering in second year.
Okay.
And they got me to think about design for one of the projects. It was a massive long span structure. And when I was playing with that from the geometry point of view, from the numbers point of view, I realized I absolutely love designing. And I was so engaged into it. Not only just drawing, just to draw and then find the best shape, which takes the numbers as in loads down to the foundations. So for me, that was very intriguing because I was drawing something and then proving it through my calculations.
Yeah.
And when I went back, I knew exactly what I wanted to do, which was design engineering, structural design engineering.
I love your answer because sometimes I think we don't realize how some of these misconceptions or some of the ideas around certain fields are. But what we put out there, people actually pick it up and they absorb it so much. And sometimes we even see that with the young ones, like you tell them who an engineer is and all those misconceptions will come into place. They start telling you, and even sometimes, even when you try to correct people, it's like still their mind is on that idea that they've had in the past. So
yeah, it's correcting the misconception, and what I realize is not just for the next generation, it's actually for their parents as well. Yeah. Because when we go because I go to schools quite a lot, I go and speak to children, and when they go back home, they share their idea and what they've learned with their parents, and that goes back to those misconceptions again, because we've not done that part of speaking to the parents as well. Because there's two different things they're looking at, and I think we need to combine them together and bring and educate parents as well about what engineering is, what does it actually mean, and then change the perceptions at that level.
That is so true. So moving on from that, what would you do in your everyday work role? What do you do? I know you've said you spend 95% of the time doing design work in the office, and the other 5, you have the opportunity to go on site to see some of your structures coming up. So how does that look like?
Before I go into how does that look like, let me tell you what does structural engineering actually is.
Okay.
So if you think of a body, right, you have skin, you have bones, you have features, you have the organs inside that's working, right? I say structural engineering is the bones bit, is the skeleton of the building. Yeah. What that does, how does skeleton work, right? You put something against your body, it whatever force you apply, it goes through the body and it goes all the way down. So that's why you don't fall down. And it's the same concept with the building. You have vertical load coming down. So you have your people walking on the buildings. You have all the furniture in the building, the use of the building, and then you have this building envelope, right? The skin. That envelope is the facade, what we call in the buildings, is the skin of your body.
Yeah.
And then all the loads from the wind goes onto the facade, which transfers it to the building itself, the skeleton. And then the skeleton elements take it down to the foundation, which is your feet. And all of these make sure your building doesn't fall down. So what I do as a day-to-day basis is come up with solutions for the problems, right? So the problem is you have a new building that needs to stand up. So I work with the architects, mechanical engineers, electrical engineers, the client, the financial team, the quantity surveyors. All of us work together to come up with the skeleton for the building, which can make the dream, the vision from an architect stand up.
That is a good analogy. I'm always saying that the human body is the best engineered product or device that we have. The human body does everything that you can possibly think of. So that's my stand on that.
Yes, sorry.
Sorry.
So I was gonna say there's one more thing. It's like there are different ways now to come up with a solution. So I do sketches to come up with the ideas. I draw them out, then I put them in the computer model. So I use the technology to analyze this. So I visualize and work on the building to make sure it stands up before it goes to site. I then produce the drawings, working with the draftsman and the wider team. So you come up with the drawings, and then those drawings go to site and then gets built. So there's a lot of things in the middle. So my day varies significantly on a day-to-day basis. So one day I will be doing calculations. The second one I will be doing analysis on a computer. The third day I might be going to site to check how is it going. So it's a lot of variety.
I like the way technology is currently incorporated almost every aspect of engineering. I know back before all of this technology, it was mostly just doing the calculation and hoping the building still stands when it's in use. But now with technology, you can correct a lot of mistakes that in the past we couldn't do. And I know right now lots of students and kids are very much technology savvy. So that is something that with those engineering misconceptions, nobody tells you. All they tell you is that you're wearing a hard hat. You're going to be working with a set of gears, but nobody is telling them that you can do a whole design of a building, make sure it's safe. Nobody tells them that. And I think that's such a shame.
Yeah. And one thing, I mean, those who do not want to go into the professional traditional route, which is to go do the A levels, go into the university, I actually work with apprentices as part of my team. Okay. So who help me put that 3D model together. They have done their A level, I think up to A level, and then they come and join us as an apprentice, work with us on projects, live projects, and do their education qualifications part-time. So if someone who doesn't want to go on a traditional route, there are many other ways you can go and end up in engineering.
Okay. That's really lovely, because I also think there is this idea that if you want to go into a certain career, this is the route. But as we keep finding out, there are different routes into getting into different careers that you want. In mentioning that, what was your own route in getting into engineering?
I actually took a traditional route.
Okay.
Which means I took the educational path when I finished my education. So before I go into my route, I know a lot of. So basically, your first step is GCSEs. You get to GCSEs, you do your subjects. Mm-hmm. I actually did not do them because I was not in the country at that time.
Oh, okay.
So I moved to UK when I was 16, and when I got here, I already had matriculations, which is equivalent of GCSEs from Pakistan.
Okay.
Then I got directly into A levels. I did maths, chemistry, and physics as my subjects.
Okay.
And I wouldn't say I didn't do them because someone told me if you want to go into engineering, you have to do them. I did them because those were the only subjects I could recognize being new in the country. I know a lot of people who can do other subjects like geography, history. You can do if you can do art, if you can do design. What's the subject? Is it design management?
Design and technology, I think.
Design and technology. If you do that, then you can actually go. You have more scope of going into engineering, especially the mechanical and electrical side. You fit the product design. You can learn how to shape, and you also learn the softwares and tools to be able to get to that point. Those are all starting points. So what you need to realize is there are many other ways to go into engineering. And engineering does not mean you are just an engineer. There are so many different types of professions within an engineering company who are making sure everything runs together. So explore all of them. And then after doing my A levels, as I said, I applied to University of Leeds for civil and structural. Did my 4 years of degree because I already decided that I wanted to do masters. So I did MN's degree. Finished that in 2011 and struggled a bit to find a job because of the recession, but then ended up taking my first role in London. Worked there for about 5 years, and here I am.
Congratulations. I have a question for you. During studying 4 years in Leeds, and then because of the recession, struggling a bit with finding work, and then doing that transition to moving to London, did you find that challenging, like having to put yourself into a whole new environment that you weren't familiar with?
Yes, it was a big, it was scary for me, honestly speaking, because I had never lived away from home as well. So that was the first time I moved out of house and out of city to be alone and then self-managing myself. But I would say it was a great learning experience, because one thing you realize is something called self-management. You start organizing yourself. You start forcing yourself into doing certain things. So my routine to be able to get to work on time, knowing that there's no one at home to wake me up, I knew that I need to wake up. So you automatically get into that. And that was a good learning experience. Knowing that no one is going to have my clothes ready for me, I knew that I need to have a program for myself to be able to wash them, have them dry, have them ready for work next day. So you learn all of these life skills when you get to that. And moving out to the London city was actually even more interesting, because it's a completely different world. Because London is a big city, it's very fast city. So you go, and I went from being in Leeds, Bradford to London, and for me it was like keeping up with that pace as well. So I would say it helped me grow quite a lot.
I think sometimes just taking a risk, it's frightening, but I think at the end of the day, you always learn a lot, and it pushes you as well. What would you say has been the most challenging part of being an engineer, or maybe being a female engineer?
Breaking the perceptions. Like a lot of times when I go and tell anyone that I'm an engineer, and it's more of a cultural thing as well, because in UK the word engineer is misunderstood. So because everyone calls themselves an engineer, so if you have someone comes and fixes a printer, they call themselves printer engineer. You have someone who comes in and fixes something, anything, they call themselves an engineer, which means the term engineer is highly misunderstood. So when I was asked the question from different people, from my immediate family knew exactly what I was doing, but if I was talking to anyone in the extended family and they asked me, why engineering, why? And I actually had to explain them exactly what I do. And I do not go around fixing things. I sit at my desk and then do things on paper using the education like maths and physics to solve problems.
Yeah.
I think that was the biggest challenge for me. And I would say when you go out in this big world of working world, you need to make sure where you're going is a good environment. And I think I've been very lucky to be able to find a very supporting network around me. So the right training, the right people who knew that I wanted to progress. So they trained me, mentored me in the right way.
That is really good. So following up from having to reteach people or have a changed mindset about what engineering is, what would you say so far in your career has been your most exciting engineering project that you have worked on, and why?
The most exciting, I would say, is there's a building where we had an existing site. The shape of the site was trapezoidal, and we had to put a square box on top. So you can imagine a trapezoid and a square on top. So which means your half of the building from above the square, because it was outside the trapezoid line, it was hanging. So it's a building, half of the building was hanging on top of people walking underneath. So that was, like, I would say for me in my career, be the most challenging and most exciting project. Especially because the engineering solution the team came up with, and I was a graduate at the time, so I was literally doing the design for it. And I had to break down that big problem, the big solution, into tiny chunks to find my way to get to that big solution and say, yes, this is exactly how it works. And I think that in itself made it super exciting and more valuable for me, because I learned another skill of breaking down the problems, the complex problems, into simpler steps.
Oh, that sounds exciting. And I think that's one of the things I love about engineering, that the fact that the problems, you're solving problems, but those problems that you're solving is impacting people's lives and making their everyday life a little bit easier. Throughout your engineering career, have you had the opportunity of transitioning through different roles so far? And how did you prepare yourself for those transitions?
Lucky enough, I have actually stayed on one part, so I haven't gone completely different in my career so far. But I have grown into different levels. So I've transitioned about 4 levels, which means for every level, I set myself goals depending on what are the requirements for the next level. What skills do I need? What skills do I have? What else do I need? Find that gap, and how do I learn that? And that is basically what you will realize is there's some, okay, let's break it down into 2 things. Okay, there are technical sides of the skill and they are non-technical, right? Technical is the actual engineering skills. How do you design something? How do you build something? That comes with experience. You learn on the job, you grow, right? And there is a non-technical side of the skills. How do you communicate? Because engineering is all about not just coming up with a solution. You need to go and tell someone. Whether it's through sketches, whether it's through drawings, whether it's through explaining someone. So that side of the skills, the non-technical that I learned, will stay with me forever, because they can help me transition into any role. The technical skills is where I identify the gaps and I grew myself into those positions. Like the things you learn. So as a graduate, you start with pure technical role. You don't have to worry about the financial aspects. Like you do think about it, but you're not responsible for them, right? It's the next level up who looks after them. You focus on your engineering skills, and then when you go to the next level, you say, what else do I need to learn? For me, it was I needed to increase my commercial awareness. I needed to understand how does the overall program work, so learn the management skills. I needed to learn the financial side of it, because that's more, it's like when you're coming up with a design, you also need to make sure it's affordable. You can't come up with a solution which the client cannot afford to get built. So there are different aspects of it. And another aspect that which is constantly growing right now is your design sustainable?
Yeah.
Right? The embodied carbon, is it future ready? Right? Are you like, when you think about it for few, like let's say 10 years down the line, is your building still going to be efficient?
Yeah.
Right? Is it still going to be useful? And if the use of the building changes, is it still will it require significant works, or will it require minor tweaks? So what we think about is, you might not, I mean, sometimes you might not even say, I will have, for you don't design a residential building for an office and something else and something else. You design it for the purpose, but you keep in mind what else can happen to it in future. So you don't design it so that they will have to demolish the building and start from scratch again.
Yeah. One of the things as well is people can visualize those transitions when you are of different engineering roles, or what engineers do aside. I think there is always that first, like, what is it that the engineer is doing? So if it's civil structure engineers, we know it's either putting our buildings or infrastructure for our roads and highways. But aside that, people forget that there are other things engineers do that it might not be on the forefront, you might not know, because like you said, if I said I was putting a 1 kilometer road down, and I said to the stakeholder, it's going to cost you £2 billion, everybody is going to start running away. Yeah. Because that is not, one, it's too expensive, and then two, how do we know that road is not going to get potholes three months down the line? So that is some of the things that engineers learn that people don't appreciate or are even aware of.
Yeah.
So I know you mentioned this slightly. What do you see into the future of civil and structural engineering, especially when it comes to technology, as well as looking at sustainability?
Technology is growing so fast. You're constantly developing programs and softwares and tools which can help engineers come up with more efficient design. Like you said before, any buildings that were done in past, there was nowhere to make sure, but we haven't seen any buildings falling down, which means the engineering was done right. But what was done was they were over-designed. They were over-designed for the purpose of that building. So with more technology coming into place, we're actually bringing it down to exactly what's required. Where is the maximum force? Where do we need the maximum amount of concrete or steel? Right? So you're narrowing it down to make the design more efficient, which means you're reducing the embodied carbon of the building. Right? So when you're reducing that, so you're reducing the carbon footprint of the building, which means you're making it more sustainable. You're, from the mechanical point of view, your technology is constantly improving. So you're not releasing as much as carbon dioxide and fumes into the environment. You're transitioning from a traditional energy producing source like nuclear power into renewable energy. Right? So these are the things that are embedded as part of the engineering solutions now. So when we come up with a design, we think about all of these. Some of them will be practical, possible, within the budget, so we implement them. Some of them have been thought about it. There's a potential for it to be done in future when the technology improves further. So it's part of everyday life now.
Yeah, because I feel like now you can't do anything without being conscious of sustainability or how we want to, or even protecting the earth. It's something that you need to think of. So at home, waste products. Okay, I need to recycle my bottles. I need to recycle my metals. I need to recycle food waste. Which maybe I think even as far back as maybe 10, 15 years back, we couldn't even be bothered. We just everything in one big chunk and it goes out. But now you have to. You
Yeah.
have to. So it's good to see that that is also for all the different engineering fields. We are seeing that also in there. What would you say about work-life balance, especially when it comes to being a practicing engineer? How important is it?
It's very important, because if you are overworked, if you're tired and you don't have a balance, you are going to make more mistakes. I am, like, depending on when the work is and how crazy it gets, it does get crazy at times closer to the deadlines. I am guilty of not having that work-life balance. And then I sort that out by taking a break after that. Right? So give myself a break, relax, come back fresh. Because as I said before, engineering is all about designing something which is going to be built. Which means that if you are tired, if you're not giving yourself enough breaks, that means you are putting risk not on yourself, but on everyone else's life as well. So it's very important. It's easily said than done. That is the reality of it, because when work needs to be done, it needs to be done. But it's something to keep in mind. If you're able to keep yourself healthy, both physically and mentally, that means you're able to perform better in your job.
I like the answer, because the answer about easier said than done, because I think sometimes the struggle is figuring out, when do I stop work and when do I start to live my life? Sometimes there is no straight cut line for some people. It's all mixed up. They close from work at 4 or 5. They're home and it's still work. They sleep, they wake up and it's still work. And I think being firm enough to say that, you know what, it's 5 o'clock, I'm shutting my laptop down and I'm going to maybe read a book, maybe run around the park. And I think that is a really difficult thing for most people, but it's not just engineers, it's all around us, whether you're a student, whether you're a worker, it's all of us, and finding that balance between work and our lives.
One thing I would say is, when you, as you said, your body is the best machine, right? When your body starts hurting, you know you've overdone it. Right? So just keep that in mind. When you're, like, for me, it's my knees. When my knees start saying, "That's it, get up," I know I have been sat there for way too long.
Listen to your body.
Yes, listen to your body.
What advice would you give to any female who wants to pursue a career in engineering, or they're thinking about it, they're not sure, they're like, is this the route I want to go into? What advice would you give them?
I would say 2 different things. One, if you have an instinct that you want to do it, give it a try. The try bit is like, you might like it, you might not, but don't just say no because of everyone else's perceptions, right? Give it a try, have a go at it, look at it yourself, and then you will know whether you like it or not. And the second is, if you're not sure because of what people will say or because of what you think it looks like, think about and break it down to the steps back. Why do you want to do it? What is the reason you started thinking about it? Because one thing that keeps me going day in, day out, is that end goal, because I want to make a difference in the lives. I want to have an impact, right? And then I wake up and it's like, if I don't do what I'm supposed to do today, then I am not making that impact. Is that vision, that big goal, right? So think about what your big goal is. If that is to make a difference to the lives of others, then engineering is one of the options. I'm going to say one of the options. I'm not going to say you have to do it. There are many other ways, but it really depends on the individuals. The females who are considering it and not sure, go and have a try. Speak to people who are doing it, right? Speak to them, because they will tell you exactly how their day goes, and then you can decide whether you would like to go through that process.
That is great advice. This brings us to our really last question, and it's, what is anything that you do that may surprise people to find an engineer involved in?
Right. Well, I love photography, but I'm pretty sure a lot of people like photography. I am trying to, I'm trying to set up a YouTube channel for myself. So this is something engineers would say, because engineers don't like talking too much and then being on a screen, right? So this is something they would question and find it surprising. But let's see how it goes, because I'm trying.
I'll take go for it. This brings us to the end of this lovely conversation. It's been a really good conversation, and then also we've learned a lot about the civil and structural engineering industry. We want to say thank you for sharing with us. Thank you for sharing your time this morning as well. Thank you, Najwa.
Thank you very much. I've absolutely enjoyed having this conversation, and I'm looking forward to this interview coming out. So good. Thank you.
You're welcome. So